Alrighty, let's get started. Any questions about anything so far? We're good? Alright. So, I graded the midterms, whoever turned them in. Most of them are pretty good. If you missed any points, you're welcome to resubmit it. 50% of anything you lost, I can give you. And last week we talked about arrays and pointers. Today we're going to talk a little bit more about arrays and functions this time. So let me just go through what we did last time real quick and have a quick review. So arrays are basically just lists of the same data type. You can have arrays of integers, arrays of characters, strings, doubles, floats, and it's basically the same thing as declaring a whole bunch of variables, right? Instead of declaring 1,000 variables, I just say, okay, there's going to be this array called A, and it's going to have 1,000 elements, and then each of these elements, if I wanted to declare another array here, so this is one way to declare it. This array here is an empty array with the values in it being just whatever random number is left in memory. Mostly usually 0, but not necessarily. If you wanted to declare, so this is declaring an array. If I wanted to declare and initialize an array in the same statement, you do it this way. You don't need to put anything in the square brackets to tell it how many elements it is, because by just stating what the elements are, it'll figure out the size. Each of these elements, so this is the first element, which is B0, second element, which is the B1, last element is B2, and each element is identified using the subscript called index. And this is me showing the different elements of this array here, so it will show 10, 20, 30. If I wanted to change the elements of the array, I do it this way, again using the indexes. So this is the first element, second element, third element. The first element always is a 0. The last element is always 1 less than however many things you have. So if the size of the array is 1,000, then the last element will be 999. I can use loops to go through the array. So this is a loop right here. The array is of 3 elements. So I starts at 0, goes to less than 3, plus plus. So the values of I that I'm going to get in here are 0, 1, 2, and those are the values that I'm going to plug in for I in between the square brackets as a subscript or index to show you the different elements of the array. And then I went and I showed you the value for this array of 1,000, and you saw that even though they're mostly zeros, there were actually a few random, really big and really small numbers in there. So that's just the nature of C++, how things are working. So if you wanted to initialize the array, then you could do it using a for loop, which is what I did right here on the line underneath it. All right, so I'm basically telling it every element, which is the A square brackets I, is going to be equal to 0, and the value for I is going to be incremented by +1 every time in the loop, so that I here is going to be equal to 0, 1, 2, etc., all the way through 999. Okay? Be careful. I did an example in here, so this is an array of doubles. Be careful that C++ is not going to give you an index out of range error like some other languages. This particular one here, we saw that there was like some really tiny number when I ran it. Again, sometimes it will be just 0, sometimes it will be just some crazy number that's stored in memory that you're trying to refer to. So try not to exceed, not try, but do not exceed however many elements the array is supposed to have, right? So this array here, C, has 2 elements which have an index of 0 and a 1. Do not try to put a 2 in there because there isn't a 2. Even though it will try to do something with it, it's not going to necessarily work the way you want it to. The other thing that I did was I showed you the difference between a character array and a string. A string is basically an object. You don't know much about objects yet, but I will introduce them later. But a string is just a character array which ends with this / or \0, which is the null terminating character. That's how it knows that this is going to be the end of the string. The string basically has this like invisible built-in null terminating character at the end of it, even though you don't see it. Okay? You can have an array of strings as well, which is this right here. And the next thing that I talked about were pointers. Pointers are another kind of a variable, right? So you have your regular variables like an x and a z, right? And then you have a variable which is declared with a little asterisk in front of it, and that is a pointer variable. And the purpose of a pointer variable is to store the memory address of another variable. What is the memory address of some variable? Well, the memory address of this variable x can be seen by just doing %x, right? And when I ran the program, it showed some number that is this right here. Okay, this number is going to change every time I run the program, so don't count on it to be the same, which is all right. And if I wanted to point this pointer variable x to this other variable little x, then I just say x is equal to %x. And at this point, now this pointer points to the memory location of this variable, which means that now if I wanted to, if I say asterisk x is equal to 100, I will actually be changing the content of what's stored in here. So I'm going to change x is equal to 10 to x is equal to 100, even though I'm not using the little variable x, right? I'm actually using the pointer. This asterisk operator is called the dereference operator right here, right? So that's how you're allowed to change the values of variables to which a pointer points to. And I can repoint my variable x, right, or my pointer x to another variable by just saying x is equal to %, some other variable's name, right? And what else? Two-dimensional arrays. Two-dimensional arrays are identified using the two square brackets. You can have three-dimensional arrays, four-dimensional arrays, etc., etc., etc. Right? A one-dimensional array is basically just a line of numbers. Two-dimensional array is a spreadsheet, just like you would in Excel. It has rows and columns. You can have three-dimensional arrays, four-dimensional arrays. Basically, if you want to have, solve some kind of a calculus or physics problem, you can do that. Okay. And the next thing that I talked about last time was recursion. I showed you in here that we have a couple ways to do a loop. To iterate through variables, I guess. So this is a for loop, right? It will show you 0, 1, 2. This is a while loop. It will show you 0, 1, 2. We can also do it with a do while loop, and there's also the recursion. And what is a recursion? Well, we're going to have a function call itself repeatedly until some kind of a condition is met, right? So this is me calling the function with a value, with an argument of 0. And what we're going to do is we're going to show the value 0, then we're going to check to see is 0 less than 2. Yes, it is. It will call. Then you're going to call the function again, but with the value of num increased by 1. Then it's going to go back, basically jump into itself, show the next value. Now it's a 1. Is 1 less than 2? Yes, it is. Call yourself again with 1 plus 1. Then it will show the 2, and it will stop because now 2 is not less than 2, and it will stop calling itself. Okay, so this is known as a recursion. And those were basically the things that I showed you last time. Any questions about this stuff? We're good? Okay. One thing that I actually showed the Thursday class and I didn't show you is pass by pointer, right? So this is last week. Last week we had arrays and pointers. And there's some examples in here. Pass by pointer, pass by reference. So I'll show you that real quick. So let's say I have, and by the way, this is going to come in handy today because we're going to do arrays and functions, and you're going to see that when you pass an array, you're passing a pointer actually. So let's say I have some kind of a variable int k, right? K is here, and this is equal to, I don't know, 78. Okay, and then if I wanted to have a function, I'm going to call it pass by value, and I'm going to call this int, I don't know, L or M. Okay, and then I'm going to go after my main, and I'm going to throw that in there, do my definition, and in here I'm going to say M. Well, actually, let me name them both the same. So this is K. I'm going to call this K also. Right? There you go. Both are K. Okay? And then in here I'm going to say K is equal to, I don't know. It's not a K. It's a K here. K is equal to, I don't know, 100. Okay? And just to move this thing in a better place, let me grab it from here and put it right there. Okay? What don't you like about duplicate or variable K? Okay, make it a capital K. Alright? So these are all going to be K's. Okay? So the next thing that I'm going to do is I'm going to ask you this question. So if I do a cout right here, I say cout K equals K, right? And then I do pass by value, and then I send the K over, and then I do another cout after it. Okay? The initial value that's going to be shown here is K is equal to 78. What is the value that's going to be shown by K here? I have a feeling that I told you about this last time, but maybe I didn't. Did I? Alright. So what's the value of K here? So I'm making it equal to 78. I'm showing you the value of 78 here. Then I do a pass by value, so I'm sending K into the function. In here, I have a K is equal to 100. So what is this going to show me? Is it going to be a 78 or 100? 78. Okay, why is that?
Because it's a local variable.
Okay, so this is a local variable K, and this one here is a different local variable K. Okay, different local variable K. Okay, so changing this one here has no effect whatsoever on the one in the main. Okay, so but there are ways to do it, and the way we're going to do that is using pointers. So what I'm going to do now is I'm going to create another function. This time I'm going to call it pass by pointer. Okay, pass by pointer. This time is going to be an asterisk K. I'm going to grab this thing and throw it right after my main here, right? And then in here what I'm going to do is I'm going to say asterisk K is equal to 100. Okay? The next thing that I'm going to do in here is pass by pointer, and I'm going to send the memory address of this variable K in. Okay, in fact, what I'm going to do is I'm going to call this something else. I'll call it, I don't know, P. Okay, completely different variable name. All right, so it's not even called a K. So this is a P here. Okay, so then what happens is I'm in here. Well, let me ask you that same question again. So now what's going to be the value of K? Is it going to be 78 or is it going to be 100? 100. Why is that? Okay, so what's happening is I am using a pointer to change the value. So what happens here, I'm sending the memory address of K into the pass by pointer function. P becomes equal to that memory address, just like I did, where is this thing? Just like I did up here, right? Just like I said big X is equal to little x. That is exactly what happens when I send my pass by pointer argument memory address. right? So little p becomes equal to the memory address of k, and then when I change p using the dereference operator, this here changes k in the main. Okay? So here pointer p points to the memory address of k. Okay? Which is why when I do p is equal to 100, that actually changes this value of k right here to 100. Okay? So that is a pass by pointer. And just because it's a C++, let me show you another way to do this. There's another syntax for this, and that is the pass by reference. Okay, pass by reference is an %p. Okay, and I'm going to throw that in there. And pass by reference pretty much does the very similar thing. And here I'm going to say p is equal to, I don't know, 99. Okay? And then the syntax for it is a little bit different though. I'm going to say pass by reference, and I'm just going to say k. Okay? And then if I do a cout after it, what is going to be the value of my k here? $99. Okay. All right. So I'm calling. It was 100 from before. I'm saying pass by reference. I'm still sending the memory address of k into the function. P becomes equal to that memory address. I change p. Notice how the syntax is different. I don't use the dereference operator when I use a pass by reference, and I don't send the memory address over when I do pass by reference. But it still does the same kind of a thing. Okay. And I don't know why I don't have it in my notes, but I'm pretty sure I told you this last time also. What's the difference between the pass by reference and pass by value then? What is the difference between this and this? The difference is that the asterisk p is a pointer which can be repointed to another variable. So just like in my example right here, I had asterisk x is equal to some memory address of some variable, and then later on I said x is equal to another variable. Okay. Similarly to this, inside here I can go and I can repoint, like say I have an int a, right? I can repoint p to the memory address of some other variable. Okay, syntax is wrong. There you go, right? So a pointer can be repointed, right? And a reference cannot. Reference cannot. Right? So what is the meaning of this? Well, this p here is permanently connected with the k. Okay? So I cannot change it. It will always be connected to the memory address of that thing. Right? But the p, it is initially connected to the memory address of k, but then later on I can repoint it to some other variable if I wanted to. Okay? So there you go. Pass by reference, pass by pointer, pass by value. Okay? So now that we know these, now let's look at how we're going to send an array into a function. Okay? And you don't know it yet, but we can make arrays of different things also. We don't have to be limited to just integers and doubles and floats and stuff. We can make our own objects, whatever we want. Those objects can be huge things, right? Each object can have thousands and thousands and thousands of variables, and you can have an array of these kinds of objects, okay? And because it will be very time consuming for me to send that whole array of things into a function, because I'm going to have to move a whole bunch of things around memory, it is easier for me to just send a pointer over into the function telling it, okay, well there's this pointer which points to the memory address where this array of objects begins. And then the pointer will know how to jump through the different elements of the array. Okay, so that's one of the reasons why we have pointers and pass by reference and pass by value. In other languages like Java and Python, which do not use pointers, this is done by pass by reference, right? Whenever you're passing a list or an array of things into Java or Python, you're passing it by reference. It's just built into the language because that's the way it should be. So let's see, what do I want to use this for? So if you noticed, in here, I have, I showed you the array. All right, so I showed you the array in one way, right? There's the array here, and I showed the array another way. So one was show the array in ascending order, the other one is show the array in descending order. Okay? And I noticed that I didn't show you the bubble sort and a bunch of other things, but oh well, we'll get to it. All right, so if I wanted to show an array, right? It will be easier for me to just call a function, right? Instead of this thing here, what if I had a function that I could do something like show array, and then I just send the array over, and then maybe I can tell it to, I don't know, put it in reverse or something, all right? Or something like that, okay? So let's say this one here is going to be true or false, right? If it is reverse, all right, something like this. So I'm going to copy this. Let me make a prototype for this thing. Void that. The numbers is going to be int numbers array, right? And this value here is just going to be a boolean, okay? Reverse. That's what I'm going to call it. Okay? And then what I'm going to do is I'm going to go write the definition. Okay? And now, instead of doing this here, instead of doing this business, right, I'm just going to grab this here, copy it, comment it out, throw it in there. This is int k. And I do need to send the size of the array. That's one of the unfortunate things of C++. You cannot figure out the size of the array from inside of the function, so you need to send the size over also, right? Other languages like Java, like Python, the object of the array object itself has like a built-in property called length, and you can see how many things are in it. Not in C++. Okay, so what I'm going to have to do is I'm going to send the numbers array, the size of that thing, right? Size of the array, and then something else. Okay, what's the size of this array? Well, it's 4, so let me just make it up here. And size is equal to 4. Okay, did I redeclare it? Okay. So the size is just going to be some kind of a number there. Okay, so it's complaining because I am giving it too many arguments, right? So I have to go and change my prototype. So it's not going to just take 2 things. I'm also going to do an int size in there. Okay, so that's that. And then I'm going to change my definition too. There's an int size also. Okay, and now what I'm going to do is I'm going to do an if my reverse is equal to true, right? And by the way, I can write this in another way. I can just say if reverse. In fact, I'm going to do that. And notice how it kind of tells me expression can be simplified to reverse. Well, yes, it can, and I will. So in here, I'm just going to say if reverse. Because reverse is a Boolean variable, it's either going to be equal to true or false, so I don't really need to compare it to true or false. And I'm going to go throw some curly brackets in there, and then move this stuff in there, like so. Okay, so if it's a reverse, do this, and if otherwise, else, what I'm going to do is I'm going to do it the other way. So I'm going to do it this one right here. Copy this. that's going to be right there. And I think that will do the magic. K. I can probably even move this stuff outside. Let me do this. So instead of it being here, I'm gonna grab this thing and put it there. Okay? So how am I gonna use this thing to show the array? In fact, why don't I make some other array here and I'll use this. Okay, I'll do it twice. So I'll do it here. Alright, so this one was show the array in reverse. This one is going to be show the array in regular order. Okay? And that is my array that I'm going to show in two different ways. To make it easier, why don't I do this all the way at the bottom, and y. Do I have a y? Int y is equal to 1, 2, 3, 4. Okay, and in here, what I'm going to do is I'm going to say show array y, size is 4, reverse is true. Right, so initially it's going to show it in reverse order, and then I'm going to do it in another way, and this time I'm just going to say false. Right, so this one here should show me the array as 1, 2, 3, 4. The other one underneath it should show me the array as 4, 3, 2, 1, if I did it right. Okay, which is, there's no guarantee for that ever. Okay, so if I run it, and all the way at the bottom, okay. Here's the array. Okay? So I'm sending an entire array, right? When I do this, I am actually sending the pointer to the array. Okay? So there's one way to do this. In fact, let me just shorten this code a little bit. Clean it up. There we go. Okay. So what I'm going to do is I'm going to rewrite this. So this exact function that I have in here, I'm going to change this numbers from the square brackets that you're seeing. I'm going to change it to a pointer. Okay. So I'm going to grab this thing, copy it, and let me write it again. So right underneath this, I'm going to do paste, and it's going to complain because it's the same function name. So let's do show array 2. I'm going to change the numbers to square brackets, from square brackets to an asterisk, just like that. Okay? And now what I'm going to do is I'm going to go in there and I'm going to do the same exact thing that I did before and keep my fingers crossed. So this is show array 2, show array 2. Do a little separator. And what don't you like? Undeclared function show array. Okay, yeah, let me write my prototype. Alright, so it's basically the same thing, right? It's the same function. The only thing that's different is I'm changing this variable here from having square brackets to making it a pointer. Okay? And if it works exactly the same way, then you're going to realize that what I'm actually really doing in this syntax right here is I'm actually sending a pointer to the array, just like I did on the one underneath it. Alright, so I'll run it again. Oops. Come on, where are you? 1. Alright, and there you go. Yeah, same thing. So again, whether you're doing this or you're doing this, the effect is exactly the same. Okay, you're actually sending a pointer variable. This numbers pointer variable actually points to the first memory address of my Y array, right? So let's say in here, what I'm going to do is I'm just going to open up an Excel spreadsheet so I can show you real quick what I'm talking about. If it opens. Okay, so you know, I have this array. Let me copy it. Let me copy the whole thing. Copy as plain text. All right, so this is my array. Okay, so maybe it'll be easier if I do this. So this is array y, is this, and then it's a 1, then it's a 2, then it's a 3, then it's a 4, right? And by the way, we can actually look at these memory addresses too. So let's have a look at it real quick. Cout, let's try this. Ampersand y0, all right, equals ampersand y0. Okay, and let's show the other one too. So there's 4 of them. So let's look at the 1, the 2, the 3 also. Okay, so let's look at these at the bottom. So these are my memory addresses, right? Oh wow, it actually zooms in. Finally, they updated it. Okay, so if you look at this thing here, right? If I have an array of y, right? This is my array y. In fact, let me try another one. Let's do a cout ampersand y equals ampersand y end all. Okay, I'm gonna run it again. All right, perfect. Okay, so this is what I got. You see it? So the ampersand y is actually just a pointer, which is the same as the first element. Okay, so actually this ampersand y refers to the same memory location as the other one after it. Okay, so this is the first one, then there's the second one, then there's the third one, then there's the fourth one. Do you notice some relationship here in these memory addresses? They're very close to each other, right? This one is a 0, then the next one is what? +4, then the next one is +4, then if you add 8 plus 4 in hexadecimal, you get a C, which is why we had to do those conversions at some point, right? So these are the memory addresses of all these different ones, right? So what I'm going to do is copy as plain text, right? So this is the memory address of that one, right? Which is basically the same as the memory address for the main thing, right? Then the next one over is this. Right, and then the next one over is this, and then the last one is this. Okay, why are these by +4 every time? What is that for? Huh? Length? And what length of what is that?
Your data element that you're storing is 4 bytes.
All right, there you go. 4 bytes, right? So each, and why is it 4 bytes?
Because it's an integer.
There you go. Integer is 4 bytes. How many bytes is a float? It's 4 bytes. How about double? 8, right? Okay? So this is what happens when I pass a pointer. So whether I say int square brackets y, it's still this, or if I did an int asterisk p, right, it would still be the same thing. I'm literally sending the memory address of where this thing starts, right? And then it is built into the language itself that it knows when I say, well, y square brackets 0, it knows, okay, start with the first one, right? When I say y square brackets 1, it's actually doing +4, right? So it's actually working with the memory addresses. Okay? Does that make sense? All right. So that is the reason why we cannot really, in C++, we can't really send the entire, we're not really sending the whole thing. We're just sending a pointer to the memory address of the first thing, and then it is built into the language to know how to hop through these different elements of the array, which are just basically places in memory, right? This is one place in memory, this is another place in memory, third place, fourth place. Make sense? Any questions? Okay, so again, when we pass an array into a function, we're passing the entire array, and by entire array, I mean we're passing a pointer to where the array begins, and you do need to know the size of the array in advance before you can tell it how many elements to show, right? Because it will not be able to figure out how many things are in the array just by, unless you put some kind of a marker in the array, just like the way, that's the reason actually why strings have a null terminating character at the end, so that it knows automatically how to work through the whole thing and where to stop, right? So if I have some kind of an array that ends with like I don't know, backslash, I don't know what, 9 or something, then I can tell it, okay, go through this array and then just stop at, maybe not backslash 9, but maybe a 99 or something. Right? Then stop at the 99, start from the beginning, and stop when you hit a 99. Those kind of things I can do. Okay, but we're not going to do that. Okay, so just like I have a single pointer which refers to a list of values, a row of values, if I was passing a 2D array, if I had like a y square bracket, then if I would be sending this array into a function, then I'll be doing an int asterisk p. Okay, there's double pointers. And if I wanted to do a 3-dimensional array, right, then I'll be doing a triple pointer. Okay, if I can click it. So that's the purpose of these double pointers and triple pointers, and really that's what they're for. Okay, any questions? Pass by pointer, pass by value, passing an array, the whole array into a function using a pointer. These are important things. So that is what I wanted to tell you. I think most of it for this week. All right. So the other thing that I'm going to tell you this week is, let's do the bubble sort. So bubble sort. Let's see if I have some picture in there. No, of course not. All right, let's Google it. So if I Google bubble sort, all right, and if you Google the bubble sort and you look at this thing, all right, here's your bubble sort, right? It's a list of numbers in whatever order, and the algorithm for this sort is you compare every two things to each other, right? If the left one is bigger than the right one, you swap their values, and then you move one down. Right, so 6 is bigger than 1, yeah, swap their values, then move, the next set of numbers down, right? Is 6 bigger than 8? No, it isn't, leave it as is. Is 8 bigger than 7? Yes, it is, swap their values. So when we do this for all of these numbers, what's going to happen is 8 is going to get moved all the way to the right, or it will bubble up to the top, which is why this thing is called a bubble sort, okay? And then once we're done with this first pass, we're going to go back to the beginning, and we're going to repeat this scenario again, compare left to right, move down, swap if the left one is bigger, move down 1, etc., etc., etc. So the second time we do this, what's going to happen is we're going to grab the 7, and we're going to move it right next to the 8. Okay, so now the second biggest number is going to bubble up to the top. And another way to visualize this is if you're looking at a bunch of data scattered all over the plot, you're sorting this thing from top to bottom, right? And then of course you can do it from the bottom top, right? Depending on how you arrange the thing. Okay, so this is the bubble sort. All right, so in order for me to show you the bubble sort, let's do a couple of things. So this is the bubble sort. Bubble sort. Okay, so let's say I have. It would be nice if I didn't run out of variable names. So I have G and H. Okay, so I have an int G which is equal to 1, and then H which is equal to 2. And what I want to do is I want to swap their values. So that G is equal to 2 and H is equal to 1. Okay, and by the way, why do you think we're comparing two things to each other in here? Why are we looking at only two things? Because this is a computer, right? The computer can only compare two things at the same time. That's how the processor is limited. As a human being, if you have a list of basketball players or whatever, you can look at them and say, oh, well, that's the tallest one right there. But the computer has to go one by one and has to compare. Basically, he has to actually measure every player's length in order to determine the tallest one, right? So it's going to compare one to another, etc., etc. So, and that's the restriction, that's the limitation for this. So anyway, so I want to swap these values. So what do? If I just say G is equal to H, what happens here? My G is equal to 2 and my H is equal to 2, right? So I lost the value for the G, okay? If I did it another way, if I said H is equal to G, right? Then what happens is H is equal to 1 and G is equal to 1. So I lost the value of G now, right? So how do I swap the values?
You need like a
temporary, right? So let's do a temp, right? So before I do this, before I lose my value for either one of these, right? And I can do one or the other, it doesn't really matter which one, okay? So what I'm going to do is I'm going to say, so this one here was lost the value for G, and the other one underneath it was lost the value for H. So what I'm going to do is I'm going to say, all right, well, temp is equal to G, then my G is equal to H, and then my H is equal to the temp. Okay, so temp is equal to G, temp equals 1, right? And then the next one is G is equal to H, so now G is equal to 2, my H is equal to 2, and my temp is equal to 1. Okay, and then the next one is H is equal to temp, well, now it's equal to 1, right? G is equal to 2, and then who cares about temp? But I basically swapped them, right? It used to be G is equal to 1, H is equal to 2, now H is equal to 1, G is equal to 2. So this is the swap. Okay? So now that we understand how the swap works, swapping two values. Okay? So now that we understand how the swap works, what I'm going to do is I am going to do this thing to an array. Okay? So let me make up a new one. And now since I did the show array function, I actually made my life easier. I don't have to do, a whole bunch of these lines of code every time I want to show the array. So it will actually make my life easier when I'm showing you this example. So all right, so I'm going to make another array, and I'm really running out of names here. What do I want to call this? D. How about D? All right, I haven't used D. All right, so the array D is equal to, let's make it a 4, 3, 2, 1, right? So that's how it is. And what I want to do is want to sort this ascending so that it becomes 1, 2, 3, 4. Okay, and I'm arranging it in this manner so that it's the worst possible arrangement basically. So I'm going to show the array first. Show array D, the size is 4, and I want to show it not in reverse order, right? So let's run this thing real quick. All right, and this is my array at the bottom, right? So this is my array D. Okay, so now the next thing is I'm going to start moving numbers, right? So I'm going to try to get this number all the way to the right. Okay, so it is, a little bit hard to visualize, which is why I'm going to go through all these different steps. So what I'm going to do is, let me write the indexes here for you. Index, all right, this is the index 0, 1, 2, 3. So those are the indexes for these, okay, which is basically this one is D0, that's the first one, all right, and then the last one is D3 basically. Okay, so I'm going to go in there and I'm going to compare the first two. I'm going to compare this one to this one, and if the left one is bigger, I'm going to swap their values. So I'm going to say, all right, well, if my left one is bigger than my right one, then I'm going to do temp is equal to the left one my left one is equal to my right one, and my right one is equal to temp. Okay? So is it bigger? Yes, it is. So when I'm done with this, it should actually, now the 4 should be moved. So when I started with, initially, it looks like this, right? And then when I go to this one, now the 4 should be here, hopefully, and the 3 should be there, maybe. Okay, I'm gonna run it again. Right, and yeah, there it is. I moved the 4 one to the right. So I compare these two. And now the next thing that I'm gonna do is I'm gonna be comparing these two in the middle. Okay, so how am I gonna do this? I'm gonna grab this whole thing, copy it, paste it in there. Right, so now when I'm done with this, the 4 should go here and the 2 should be there maybe. But this time I'm not comparing the first and the second, I'm for comparing the second and the third. So this is my, I'm going to change the 1 to 2. And I'm going to change the 0 to 1. Right, and then I'm going to run the thing again. And yeah, there you go, 3, 2, 4, 1. Right, so I moved the 4, 1 to the right further. So that was me comparing these two in the middle, right? Index 1 and 2. Now the next thing that I have to do is I have to compare the last two numbers, right? Basically index 2 and 3. So I'm going to go down to my sort. Where's my sort? Oh, here. I'm going to copy this thing. Okay, I'm going to paste it in there. This time I'm comparing the last two elements. So the 2 becomes a 3. And the 1 becomes a 2. Okay, so when that is done, then hopefully the 4 goes here, and the 1's probably going to be here. Okay, I run it again. All right, there you go. Yeah, we move the 4 all the way to the right. All right, so this was just for 3 numbers. All right, so for 3 numbers, I had to do this one time. Or sorry, for 4 numbers, I had to do it 1 time, 2 times, 3 times, right? If I had, 1,000 numbers, I'm going to have to do it 999 times, apparently, right? So I don't want to do that. I want this thing to happen automatically as many times as it needs to. So I need to come up with some kind of a relationship of how many times I need to repeat this based on the size of the array. Okay? So let's look at this. So I'm going to say, okay, well, if this is 0, I'm going to call this I. And the 1, what would you want to call it? I plus 1. That makes sense, right? And then what is the I initially? I is equal to 0 initially. That is the initial value. Okay? So I'm going to put like a little comment in here. So I starts at 0. Okay? And then the same thing happens for every other time, right? This is my I, right? I is equal to 1 here. And then the I plus 1 is 2. Then I go to the next one. Then I have another I here. I is equal to 2. Right? And that's the last one. Okay? So this is the last I is equal to, what's the size of my array here? How many things are in my array? 4, right? Is equal to the size minus 2. Right? So this here is 2, so 4 minus 2, right? 4 minus 2 is equal to 2. That's how I got the 2. All right, so now I have a relationship in terms of the size. I know this thing is going to start at 0, and I know that it's going to end at size minus 2. So now that I have visualized this relationship, I can just go in there. I'm just going to comment this piece out. Here, take this out. Okay, and then I'm going to make a loop for int I is equal to 0 and I is less than size, which was 4, right? I plus plus. If I do it this way, what are the values of I that I'm going to get? I is equal to 0, 1, 2, 3, right? Did I want a 3? Nope, I wanted it to stop at a 2. So I'm just going to tell it, okay, well, let's do a 4 minus 1. So if I say size here, size is equal to 4, right? Then this here is going to be size -1. Okay, so now it stops at a 2. And now that I have this, then I'm just going to grab this if here. I'm going to copy it, paste it in there, and instead of a 2, I'm going to change this to I. Instead of this 3, it's going to be an I plus 1. Right? So all the 2's go to I, and all the 3's go to I plus 1. Okay? And when it's all said and done, this loop with an if in it should happen 3 times, which is as many times as I wanted it to happen. So when this is all done, the end result should still be the same. I should still have a 3, 2, 1, 4. The 4 should be all the way at the end. If I run it, there it is, right? Still the same result. So I was able to bypass, copy pasting this thing 3 times. I can automate it so that it happens as many times as the size of the array is. Okay. So now the next thing is, in order for me to move the second biggest number all the way to the right, as far right as possible, what do I do? Any ideas? I can make a nested loop, right? So if the idea behind the nested loop is, okay, so I had to do this one time. If I did this loop one time, I move one big number all the way to the right. If I do it 2 times, I'm going to grab this thing, and I'm going to do it another time, right? So now when this is done, now the 3 should be moved all the way to the right. So I'm going to have 2 numbers arranged. Right? And there you go, 2, 1, 3, 4. So that was, I moved it here, right? 2, 1, 3, 4. If I grab this thing, I copy it one more time, and I paste that in there. Now the 2 should be moved all the way to the right, which is basically, the whole thing is sorted at this point. So if I run it again, now you have a 1, 2, 3, 4, and the whole thing is sorted. Okay? So now, similarly to what I did with the other thing before, right? Instead of me copy pasting this thing as many times as I have to, depending on the size, I'm going to have to figure out a relationship of how many times I need to repeat this, depending on the size. And fortunately, you can see that this thing happened 3 times, which is as many times as the previous thing happened, which means that this other loop should also happen as many times as this loop. So both of these loops should happen, or the other loop that I'm going to write is going to happen as many times as this other loop that I have right here. So I'm just going to I'm going to comment this piece now. All right? And I'm going to grab one of these. All right, I'm going to throw it right here. Then I'm going to go and I'm going to write another loop. And this time I'm going to have to come up with some other variable name. Call it J. Right? So this loop happens as many times as the other one underneath it, as we saw, right? It happens 3 times for me to sort it. And then I can just go and tab this thing, right? The only thing that's inside of this loop is this loop, and the only thing that's inside of this loop is this if. And that's why I don't need to have the curly brackets. And then if it's all working the way I want it to, then the array is going to get sorted in ascending order like this. So I'll run it, and there you go. Now this thing is sorted. Okay, so this is your bubble sort. Bubble sort. Okay, make sense? Any questions? Yes?
I'm sorry, but can you kind of explain exactly what that top one's doing again?
This line?
Yeah, that one.
Okay, so this loop here, this loop makes the other loop repeat 3 times. Right? So instead of me having to copy paste before, I said, okay, well, let me see how many times I need to repeat this loop in order to get the same thing, in order to get the whole thing sorted. Well, I figured out that this here happens 3 times, which is as many times as this other loop inside needed to happen, right? So initially I said, okay, well, I need to do this swapping thing 1, 2, right, 3 times, And because of that, I came up with this loop here, which is going to automate this part on top. So similarly, I said, okay, well, I have to do this 1, 2, 3 times, right? So basically, this loop is going to repeat this inner loop here. So what the outside loop, so this loop here is actually, so this loop, outer loop, is to sort all the, or is to move all the numbers to the right. Okay? So this, right, if I can spell it, let me spell right. There you go. Okay. And then this loop on the inside, this loop moves the biggest number to the right. Okay? So if you're looking at the picture here, the inner loop is the one that does this thing right here. It basically compares left to right and moves the biggest number all the way to the right. Right? So that's the inner loop. The inner loop's job is to move the biggest number to the right. The outer loop's job is to repeat this process for as many numbers as we have. Right? So now that this loop is repeating again, the reason it's repeating is because of the outer loop. Make sense? Nice question. Okay, but one thing that I can improve here a little bit is actually the inner loop, which is the one that moves the biggest number to the right, only has to go all the way to the right the first time. Right? Once I have the 8 all the way to the end, I don't need to compare 7 to 8 because I know that nothing's going to get moved. So what that means is that the inner loop has to happen one time less every time I do this. Okay, so I could improve the efficiency of my bubble sort by reducing how many times this loop is going to happen based on the j value. So how do I do that? Right? So initially I want this thing to happen size minus 1 times, right? So go all the way to the end. The second time I want it to go size minus 2. The third time I want it to do size minus 3. So how do I do it?
Started at size minus 1 and
Subtract.
increase it by 1.
I can subtract j from this. Right? Does that make sense? So the first time I'm going to do this loop, j is going to be 0, so this loop is going to happen size minus 1 times. Right? The second time j becomes 1, so then we're going to do it size minus 2 times. Right? Size minus 1 minus 1. Third time is going to be j is going to be equal to 2, so it's going to be size minus 1 minus 2. So basically every time we go through this loop, the one on the inside is going to happen 1 less times. Does that make sense? Okay, so let's see if it still works, because I don't believe myself. Run it. And yeah, still sorting. Okay, so now at this point, now that I have my sorting algorithm down, what I'm going to do is, why don't I make a function to sort things for me? Right? I'm going to go in there, I'm going to make a function. I'm going to say void bubble sort. And the bubble sort is going to have an int numbers, and actually try to recycle as much as I can. What do I call it here? This is an array D. Alright, I'll call it a D. So this is the D array, and it's also going to have a size, and we're also going to have a reverse in here, because I'm going to build in how I want to sort this thing. I want to be able to have to sort it in ascending order or in descending order, however I want. Okay, so I'm going to get this. I'm going to throw it after my main, wherever that is, right here. Okay, then I'm going to grab this piece of code here, all of it, copy. I'm going to throw it in here, and I got to declare another variable temp somewhere. Okay, Okay, so now this thing should sort it the same way as before. So that means that in here I can just say, oh, hold on, let me comment this out. Comment this out, and then I'm going to say bubble sort. Come on. Come on, autocomplete. Bubble sort the array D, size 4, and this one is whatever, false. We're not going to use it for now. Okay? So when I call the bubble sort, this show array should show me the same thing, 1, 2, 3, 4, if it's all working the way I wanted it. Right? And then by the way, that's one thing to notice, that remember that since we are passing a pointer to the original array, if I was to change the array inside of my function, right, I'm actually changing the array that was outside of the function, right? In other words, just like I did with the, where's that example? Just like I did with pass by pointer, if I'm changing the pointer here, the value of the pointer, I'm actually changing the value of the variable that was in the main. And that is exactly what's happening in my bubble sort, right? By changing this array here, I'm actually changing the array that was in the main because I passed the pointer to that array. Okay, so I'm going to run it again. All right, and voila, again, 1, 2, 3, 4. Okay, so now maybe you can help me out. I want to do this in reverse. So this was sorting in ascending order. All right, so let's do this. If not reverse, right? In other words, also known as if reverse is equal to false, right? That's what I'm saying here. So if it, or another way to say it is if reverse is not equal to true, right? That's basically the why we have a not in front of it, right? Basically, it's not equal to true. So many ways to write the same thing, whether you do it this way or this way or this way. I personally don't care. The compiler might tell you, oh no, you can make this more efficient and blah, blah, whatever. Okay? So while you're learning, I really don't care that much about how long you write your code. So I'm going to go in there. I'm going to run it again. And this was false initially, so it's not true. So hopefully it should sort it the same way. And yeah, okay. All right, so now what I want to do is I want to sort it in reverse order. All right, so in other words, if I have an else, all right, I hate it when it does this. When I do this, just to mess with me or not. Okay, so if I have an else, how am I going to do this in reverse order? What do I need to change in my bubble sort to make this thing sort in reverse? I'll throw it right in there. What do I need to change? What do you think?
It has to start at size -1.
Actually, it's simpler than that. But that's a good guess. Let's put it this way. I only have to change one thing. From this to sort, which sorts in ascending order, to this, which is supposed to sort in descending order, I got to change one little thing. What is that?
Is it less than?
Yeah, I just flip this around. So instead of the one on the left to be bigger than the one on the right, swap them if it's less than. And now what it's going to do is it's going to move the smallest number all the way to the right. Right? And then it's going to repeat that process over and over again. Okay? So let me try it. So this was the bubble sort show array in ascending order. Then I'm going to do bubble sort true. Right? So then hopefully this, if I do another show array, after this, then it should be 4, 3, whatever. So let me just run it and see if it shows it. So this is 1, 1, and still does it twice. What did I do? Oh, I changed this to true. I gotta change it to, wait. Show array. No, show array false should be the same. What don't you like? I think it's got something to do with maybe the curly brackets. For if and corresponding else. There you go. Yeah, something with the curly brackets. I don't see why though. Whatever. Okay? So I just had to add an extra set of curly brackets for this to work, but there you go. So this is sorting in ascending order, sorting in descending order, and it's basically the same thing. You just flip the less than to greater than, and it's the same. Okay? Any questions? All right. Let's see what else I want to tell you. Okay, so what other things do we want to do this week? Arrays and functions. So there's going to be, lots of practice with arrays and functions. Oh, look at that. I pretty much gave you the answer for the bubble sort, right? Finding the min and the max and the average. You already know how to find min and max and average. Let me just show you how to do it with an array in case you forgot. All right, I'm not going to put it in a function, but the exercise is to put it in a function, right? So let's say I want to find the min number in the array D, right? Of course, I could sort the thing and look at the first one to find the min and look at the last one to find the max. That's fine. But there's another way. You could just say, well, I'm going to have for int I is equal to 0, I is less than size, I plus. Just like we did before, we're going to have some kind of a variable int min, right? Min is going to be equal to, I can actually make it easier for myself. I can say min is equal to the first thing in the array, so D0. I'm going to make the loop start at 1 because I already looked at the 0. And I'm going to tell it if any of my elements, any of the di, if any di is less than my min, then the min is going to equal to that element. Right? So if any element is less than the min, that's your new min. All right? That's finding the minimum. Any questions? Cout min equals min. And okay? So that's how you do that. So there's your example for the min and the max. The average is, you should know how to do that by now, right? Sum all the things in the array divided by the size of the array, and you got your average. First and the last element, right? If I wanted to look at the first element of this array here, what's the number in between the square brackets for that? What's the first element? 0, right? And what's the last one in terms of size? Size minus 1. So there you go. That's your answer for this one. So there's a number 58 in here that tells you, given an array of integers of different size. So these arrays could be of different sizes, right? Given an array of integers, return true if 6 appears as either the first or the last element in the array. The array will be a size of 1 or more. Okay? And in here I also show you how to find the size of an array, right? If you do size of array, that will actually return the size of the entire array. So if you have an array of integers, 4 elements, the size of the array is going to be 4 times 4, so 16 bytes. Size of array square bracket 0 will be the size of an individual element, right? So let's say this one here was 16, because it's an integer array, assuming, then this will be what? 4, right? So if I divide 16, which is the size of the whole thing, by 4, which is the size of the individual element, just using the bytes as size, I can determine how many elements I have. Okay? So that's the C++, business for finding a size. And again, remember, you cannot do this inside of the function. So you have to find the size before, you send that information into the function. Okay? If you're trying to find the size of the array inside of the function, it will show you just the size of that first element. And it's not going to work. Okay? Because you're sending a pointer to the array and it's not going to work the same way. Okay? All right, so the first and the last is pretty simple. And common end is also relies on the same kind of idea. Given two arrays of integers, return true if they have the same first element or they have the same last element. Does that make sense? Any questions? If I have an array D, right? What other array did I have in there? I'm running. What's the name? Give me one name. What do you have here? This is numbers. Come on. C, no. B. All right. I have a B also. All right. So if I wanted to look at the first and last elements, right? So compare first element of one array to another array, right? So basically, if my what's this one? D0 is equal to my array B0, right? Very easy. And then same thing for two arrays here. Since this is going to have to be a function, you're going to have to figure out the size before you call the function, and you're going to have to use the size of both of these. Okay? The first element is easy. It's always 0. Last element is also easy. It's just the size of the array, each individual array minus 1. Okay? So that's the common end business. Then I have count twos. So let's say I have some kind of an array. And this is my hint for your P5859. P5859 hints, right? And we're already at 59. Okay, so whoever's not doing their work are not gonna like it. So 59, 58. So now the other one is counting how many times a specific element appears in the array. That's what this one is for. All right. So if I have, let's go with a character array. Where's my character array? All right. This was my char array. I'm just going to copy this thing at the bottom so that we know what we're working with. Okay. So what I want to do is I want to find how many times the letter L appears in the array. Okay, so I make a loop for, this is 1, 2, 3, 4, 5, 6. Let's say it's 6. Okay, so let's put size is equal to 6. Size is equal to 6. And by the way, I could do size is equal to size of char array, the whole thing, divided by size of one of these elements in char array. Let's say the 0, 1, the first element. So now I don't have to go and count every time. All right? So I'm going to go in there for int I is equal to 0, I is less than my size, I plus plus, and let's make a count variable, int count else, right? I'm going to have to make it equal to 0 initially, because remember, C++ is not very nice for initializing things. And then if my elements, any element in the char array, if any element in the char array is equal to the letter L, then I'm going to count it. Okay? So there you go. That's how you count how many times count else appears in the array. Any questions? Okay, so this is your hint for the other one, 55. P55 hint. Okay, and I pretty much gave you the answer for the bubble sort. Okay, that was the next one, the min-max, common ends, the node 23. See the node 23. Okay, so you're given an array of any size, return true if it does not contain a 2 or a 3. Similar to that other one here, right? This is how you're going to be looking for a 2. Same way you're going to be looking for a 3. If it does not have a 2 or a 3, return true. Okay? Any questions? Got it? I hope. All right. So that is pretty much all I wanted to tell you. Okay? Look at some of these older lecture notes and videos for more hints. I remember when I taught this class in the summer, I was pretty much giving them even more answers than I'm giving to you. But you have more times, so more time lets you, get this done. So you don't have to go through the whole thing in like 6 weeks' time, maybe less. All right, so arrays and functions, and just more different things we can do with arrays. Arrays are very important when we get to data structures, which is your next computer science class, hopefully, maybe, or it's in your future. You're going to have to do a whole lot of arrays. It's like arrays every time, unless we're going to do some crazier things than arrays. But arrays we can do all kinds of different data structures with arrays, right? So if I'm going to talk about a queue or a stack or some of these other data structures, I will first show them to you in terms of an array. What is a stack? Well, it's like a stack of plates. So it's like an array that you can only add and remove from the top. What is a queue? Well, it's like a line of people. So in the line of people, the people come at the end, at the rear, and they'll leave at the front. So I'm going to get an array, and I'm going to restrict the different things that I can do to it to only add on one end and remove from the other end. Those kinds of things, right? When we talk about trees and stuff like that, which is like an organizational chart, it can also be represented with an array, right? So a lot of these different complicated concepts can be illustrated and can be accomplished with arrays, and I'll show it to you. So that is all I want to tell you about arrays. They're very important. Same are also pointers, very important as far as these different things that I showed you. And yeah, that's I think all I want to tell you. If you don't have any questions, I think that's all I have for today. And yeah, we're already on week 10. We're getting close to the end. Let's see what else we have. This is pretty much the main stuff. If you know arrays and functions, the rest of it I'm not really going to require you. Actually, do I have it on the final project? Final project I assign in week 12. And you're going to be surprised to see that it's very easy if you show the original array, show the array in reverse. I kind of gave you a whole bunch of these already. Show the lowest value, highest value, the sum of the numbers in the array, average of numbers in the array. Maybe I'll change it a little bit, okay? But basically, the bottom line is if you have been doing the homework, it's a gimme, it's a free final exam, basically, okay? And you can work on it ahead. If you finish earlier, good for you. Yeah, I mean, I had one student finish this class in 3 days during the summer. Yeah, I had to grade all that stuff in like 3 days. Okay, so what else we got to do next week? We're going to be doing extra credits things to allow people who are behind to catch up a little bit, right? That one extra week, 11, is going to be a bunch of extra credits stuff. Then we do the final project, which has to do with just arrays and functions. Then we're going to be doing files, input and output, just like you read from the keyboard. You can read from a file, just like you show things in the terminal. You can show show the results in a file. Then I'll tell you about structures. Then I'll tell you a little bit about classes and object-oriented programming to get you warmed up for the data structures class. As far as the data structures class, I would highly recommend that you took Java before you took your CSIS46. You could take the CSIS46 right after this class, but if you took the Java class, you're going to get more experience with objects. because Java jumps right into objects from the very beginning. Okay? So what I'm going to cover in week 15 here gets covered in day 1 on Java. Okay? So you're going to get a lot more comfortable with objects and classes, but if you don't take Java, there's no problem. Also, I can teach you without that class too. Okay? Most schools, like for example, Hartnell College only teaches one programming language. They don't have Python, they don't have Java. You go in there and you learn C++ for 3 semesters, and then you transfer, and then hopefully that school where you're transferring didn't expect you to know Java. Okay, in MPC, they're only doing Java. Well, they actually have a C++ class in the middle, but that's not required. So in Hartnell, you take your intro to programming with C++ and your data structures in C++. In MPC, you do it with Java, and in here, I offer both. So, hey, I highly recommend that you do both of them. Okay? Java is the highest paid language in Silicon Valley. Python is the second highest. So if you haven't taken Python, take it. Yeah, so that's all I have. And yeah, I'm going to post this for you. Let me know if you have any questions. Come see me in the office. You know the drill.